So hi, as Dragana presented me, I'm Nenad Jončić. I'm coming from National Museum of Serbia. I'm mostly dealing with what we call now digital archaeology, and I'm special in the, let's say, 3D recording and representation of those data in cultural heritage. I work on several European projects on these topics, and I will try to show you and present you maybe something that can be useful for your work, maybe not just in presentation, maybe also in analyzing the monuments and things. I will speak about few different methods and technologies for creating the 3D models. What is, let's say, the advantages of these things, and what can be very useful for you, and what can be the final result, let's say, for presentation to the broader audience. So let me share my screen just a second. So, okay, this is the one. Like I said, so yeah. So I told you that I will speaking about 3D methods and techniques. So all of you probably have some knowledge about that. This is probably not the first time that you're hearing about these possibilities and these methods, of course, but I will list them and tell a little bit about them. So first one, and probably the most common and most used, is photogrammetry. Also, we have laser scanners, and it's, let's say, the different method with the similar results. Circular scanner, again, very similar thing. Reflections transformation imaging, or RT, that is most known, is a little bit different technique than the others, and the new one maybe not so common and not so popular is mobile device slider scanning. I will speak more about that. So basically what we are doing, we're collecting data with different devices. We create a 3D model, and then we manipulate it with that what we got. So with photogrammetry, we go around the object, take the photos, get the set of the photos, we process them, get the 3D model. 3D model can be used in different ways. And next method is laser scanning. I use this this type of the laser scanner because I used to work with that one, but there is different types, and even for smaller areas, those one can be used for big areas, but also when you scan something big, they're very precise, so you can choose the part that you're interested in. This allows you with the photogrammetry and this one, you can scan different things. I will speak a little bit about that. So all of these different techniques and methods give you different possibilities for working with 3D. So with photogrammetry, you can make a very small objects to, let's say, the big sites and even towns. So it's kind of similar with the laser scanner. Laser scanner is not built for small objects, but if a small object in the scene that you're scanning, you will get the high quality 3D model even of that small object. So in some way, those two techniques can be used in similar situations. To light scanner, yes. It's very precise, very good results, but not for very big things and very big monuments. It can be used, let's say, for monuments and the small finds. Then reflecting transformation imaging, it works a little bit different. Yeah, I didn't explain about circular scanner. It works with the light source and light patterns, and then create a 3D model based on that. In this case, it's similar to the photogrammetry. You're using photos, but you're using the light source and changing the light source from different angles to get the 3D model that can, with this lighting, can give you a lot of details about that and helps to read inscription, but you probably know about that. This last one in this presentation will be mobile device LiDAR scanners. I'm not working for Apple for sure, but I'm using that a lot because it's give us good enough results, and it's fast, accurate, georeferenced, and let's say the cheapest version of all that I presented until now. So speaking now again about the size of the object that we are scanning. Like I said, in first two versions, you can scan the bigger things, let's say buildings, sites, and these kind of things with the laser scanner. So this is the one things. The other thing is circular scanner for smaller things like monuments, but not too big. The third thing is RTI. So it's basically because of the dome and the size of the dome, it's focused on the smaller things. The most flexible is photogrammetry and can be used from everything from the big scales to the small scales objects. And then mobile LiDAR device scanners that I will speak mostly about that can be used for even for a bigger structure, but there is some, let's say, borders, like the laser scanner or this LiDAR scanner works only on the 5 meters. And if you have something, let's say, long, and it's lay on the ground, it's not a problem. But if it's a tall building or something like that, or monuments, this can be a problem for scanning. And let's say those are disadvantages of this method. But I will speak a little bit more about how it works. It's using camera, and in the case of the phone, you have 3 camera. It's basically, even with the new versions, you have upgraded cameras, but the LiDAR is the heart of these things, and the range is unfortunately 5 meters. In the case of the iPads, it again works on similar things. It works on the same way, with different kind of the camera. So the result is a little bit different because of the camera, and can be it's better to use for bigger things because the cameras on the iPhones are a little bit better. I will show you a few models and how that can be used. On the left side, you can see the video of the monument that scanned with the iPhone thing, and then on the right side you can see the results in without texture, without anything. That can you see? Okay, this is a rough model. It's not so good. It's everything depends on quality of the scan. I will speak more about these qualities and disadvantages. I will now show you a few examples how it looks and how can and the results are, let's say, pretty good. And good thing is that it's very easy to make this kind of the animation. If you pay attention on the details, of course, I'm not sure that it looks so good on the screens now, but the details are very good. The texture is actually, I will explain that. The texture is what we see, the colors and these kind of things. So in this case, it's 8K, so the results were perfect in that case. But let's say maybe the geometry is not always the better, but for kind of presentation, it's, let's say, more than enough and it's good. Like I said, I will speak a little bit more about quality, precision, and production speed. And those can be very interesting stuff for us, especially if we're speaking about presentation. In these three case studies, it's actually the one case study. It's the same objects scanned with the three different techniques. Actually, sorry, just a second. It's the first one is scanned with digital camera. You can see the data about it, how and how many photos, the time taken for processing, software that use, how good are the results. In geometry, this is vertex and spaces. And also very important thing is the storage. How big are the data that you're collecting during this process. So in second example, you can see the same thing done with the iPhone camera. Number of the photos, photographing time, software that's used, versus faces, storage space. The texture is very important things. And you can see the difference that now the texture is even better. But in this case, vertices and faces are not so good. Overall processing time is 15 minutes, so it's shorter, and even in the time of taking photos is also shorter. In third example, let's third way, we scan with the LiDAR. vertices and faces are better than in photogrammetry done with the phone, but it's not so good like with the regular photogrammetry. The storage space is very small. The textures is, let's say, the best. So the scanning time is 5 minutes and overall processing is about similar time, like 4 minutes. So let's say in 10 minutes you have the results that are very useful. How can be presented? Of course, you saw the video, but on the right side you have another way of presentation, and this is AR, and basically everything is included in those softwares that can be downloaded on the phones, and they are free. This is the very interesting thing. I will speak a little bit about metadata, because I mentioned before when I compare the quality and everything, this is how we usually collect metadata and how we keep them, how we actually distinguish them in technical and descriptive metadata. So, like I said, the advantages and disadvantages of these softwares and techniques based mostly on LiDAR mobile scanning is what is the best in this case is fast scanning process, slow experience needed, processing time, small file, good texture, fast rendering of presentation video, different possibilities for creating videos, 3D exporting models, point cloud format, price, georeference. The disadvantages, like I said, number of vertices and faces, especially compared to photogrammetry laser scanners and structural light scanners, and possibility to scan a small object from all directions. That's mean if you have something small and you want to record the side that is actually lying on the table, you cannot do that, because when you move the object that you're scanning, it's let's say confusing the software in that moment. And I will show you a little presentation. After that, I will show you actually how we use the 3D models gained from the laser scanning, and this will be maybe interesting for you. Like I say, is the future of these things bright or dark? I think it's bright. The cost of scanning is very small. Even the device is not so expensive for all the other things. Even for photogrammetry, usually you don't need just a camera, you need the lenses, you need the software for processing, and this everything costs. I'm not going to speak about the scanners because they're far more expensive. Like I said, the results are useful and good, so I will show the example how it looks in the end. It's a very short video. We made it in Unreal Engine for some project that we have. So you can just briefly see the monuments placed in virtual reality in the space. We organize them in a way like a lapidarium. And let's say it's very easy to manipulate with these things because they are not too big. They are good. So basically, if you have any questions or anything, I will be very pleased to tell you about everything that you want to know.